Okay, good. Sorry. So, again, we're going to take a generic function here, and we're going to perform some transformations. And each one of these letters, the A, the H, and the K, are all going to perform some different kind of transformation on our graph. Okay? So I'm going to kind of go through what those different things are, and then we'll see some examples in our book. Okay? So, we've already talked about a few of these. For example, this plus K at the end. Okay? So this plus K right here, I'm going to kind of maybe draw an arrow out this way. Okay? For K values that are positive, that means greater than 0. Okay. Does anyone remember from, it was Thursday, so I mean it might be a little while ago. Does anyone remember what did that plus K do to our graph at the end on the outside? Does anyone remember? Excuse me. Thank you. Okay, let me see if I can pull up in our book here. Yes, here we go. Okay. Remember we talked about this on Thursday. We did some problems here. For example, we took the function f of x and we added 4. Right? And if you remember, there was the original function f of x right here. Is just this like little graph right here, a little sawtooth looking thing. And then that f of x plus 4 made it shift to here. Okay? So how is that, what kind of transformation is happening there? What happens? Up how much? Yeah, up 4, exactly right. So, in this case, this plus k, if k is greater than 0, that means we're expecting our graph of f will shift up k units. Okay? So for that k there, if k is greater than 0, and that's supposed to be a little arrow. Okay, if k is greater than 0, that means f of x shifts up k units. Well then, if k is less than 0, that means f of x will shift in which direction? Yeah, down, right? It's just opposite. And if k is 0, what happens? It doesn't go anywhere, right? It stays the same, right? Because if you're shifting 0 units, it's staying where it's supposed to be, or where it started. Okay. Okay, great. So that's what that plus k at the end of the outside of the function. So outside of the function, that's going to shift it up or down k units. Okay, depending on whether k is positive or negative. Okay. So this next one right here, the h, I'm going to kind of draw it over here. Okay. So x minus h. If h is greater than 0, so it's like x minus a positive number here, x minus a positive number. If h is greater than 0, that means we're going to shift right h units. Okay. So if h is greater than 0, that means x minus 3 or x minus 10 or x minus 100, okay? That means it's going to shift right that number of units, which is kind of backwards. If you see an x minus a number, you might think, oh, x minus a number, that means I should shift left, because kind of like left is like a minus direction, right? And plus would be like a positive direction. But it's kind of backwards from our shifting up and down. Here, if we add a positive k, it shifts up, which makes sense. Here we add a negative k, we're going to shift down, which again makes sense, but here it's kind of backwards. If we subtract a positive number, it goes right, and then if we subtract a negative number, we're going to shift left h units. Okay. All right. Excuse me. So now we're going to look at one more letter here, one more parameter. So we talked about H, we talked about K. Now we're going to talk about A. What does A do? And this is one that we did not talk about on Thursday. We skipped this one. So I'm going to do it over here. Okay. So, if A is greater than 1, so we're going to multiply that function there by something greater than 1. Okay. What that does is that is a vertical stretch by A. Okay, vertical stretch by A. So it's a multiplicative relation. We multiply this. So if like A is 2, for example, our original y coordinate will be twice as much. Or if A is 3, it'll be 3 times as much, so on and so forth. Okay. If A is between 0 and 1, so if 0 is less than A is less than 1, so it means we're multiplying by like 1/2, 1/3. Instead of a stretch, what will that be?
Shrunk.
Yeah, shrink or shrunk. Exactly right. Okay, so we're going to vertical shrink. Okay, by again A. And again, we just multiply. It's easy to fix. So you know, if A is 1/2, you take your normal y value and multiply by 1/2, and that's how much it shrinks down by. Okay, and then if A is negative, so let's put A less than 0. That is a reflection over the x-axis. Oops, can't spell here. Okay, so if A is less than 0, that is a reflection over the x-axis, and then a stretch or shrink. Depending on if it's like a negative 1/2, that'd be a flip over the x-axis and a shrink, or if it's like a negative 5, that'd be a flip over the x-axis and then a stretch. 5. Okay, so those are all the different parameters that we should be comfortable, you know, with kind of like using. Okay. So let's look in our books here. Keep this paper handy, okay? Don't put it too far away because we're going to be using it to help us here. But let's look in our books on page 41, number 6. Okay, page 41, number 6. And we're not going to do all these, okay? But we'll do a few of them here at least because, you know, like number 5, I'm not going to worry about it. It's a horizontal stretch. But page 41, number 6, please. Yep. Oh, I'm sorry. Yeah, Carlos. Leave you hanging out here in the drum. So take a look there at page 41, number 6. Okay, now the directions, well actually there's 2 sets of directions, right? We've got to be careful. The directions at the top of the page, which are for these problems, it says write g of x in terms of f of x after performing the given transformation of the graph of f of x. So here's our graph of f of x, and we want g of x to stretch f of x vertically by a factor of 2. So that means we're going to write g of x so that g of x is equal to, and then how should we write it so that we're stretching f of x by a factor of 2? Where should we put that 2? Where should we go? Say what? You're not sure? Okay. Okay, yeah, no, for just writing the function. We'll talk about how to graph it here in just a second. Yeah, it's the number in front there. So instead of just g of x equals f of x, if we want to stretch it by a factor of 2, it'll be 2 times f of x. That's how we know. That's how we can indicate that g is going to be twice f of x, or stretched by a factor of 2. Okay, so then how do we actually do this? What do we do? Well, we can take a look at our points here. Right, I can see 3 points. We got like a 0 here, we got a 0 here, and then we have a y-intercept right here. Okay, so now we want to stretch those points vertically by a factor of 2. So for example, this coordinate right here has a coordinate 2, 0. Okay, and we want to do twice the function here, so twice f of x. So we're going to take our 0 and multiply it by 2. But what's 0 times 2? It's still 0. So we're going to have, this point stays the same, it doesn't move anywhere. Okay? Because twice our function there is just going to be twice the y-coordinate of 0. Okay, same thing here. If we look here, the y-coordinate is still 0, so it's negative 2 comma 0. Again, we're going to do twice that y-coordinate, but twice of 0, still 0. So this point is still right here. And then I have one more point right here, and that's the coordinate 0, 2. Okay. What will the new y-coordinate be, though, if we're stretching it vertically by a factor of 2? It's going to be now 4. Exactly right. So instead of the point 0, 2, again, the x-coordinate stays the same. It's just vertical stretch here. So we're going to multiply this y-coordinate by 2 and go up to here. Okay, and so now we have this point. We have this point. Okay, 0, 4. And we go down to there. So we're just going to kind of go up to the 4 and then back down to the 2. And there we've stretched it. We've stretched by a factor of 2 there. So there it is. We just stretched it up, right? Times 4. Or sorry, not times 4, times 2. Multiply the y-coordinate by 2 there. It's a vertical stretch test. Questions on that? All right, let's turn the page. Okay. And let's take a look at this next one here, number 7. Okay, let's see. Can I get that to fit on there? I think I can if I do it this way. Thank you. Okay, so number 7. Oh, I'm going to have to like scoot it up some too. Okay, so there's number 7. Now the directions here say compress the graph. So that's a shrink, right? Compress the graph, but we want to do horizontally. Sorry, we'll do 8. I want to do the vertical. There we go. Compress the graph of f of x vertically by a factor of 1/2. So then we want to write that function here. So it'll be g of x equals, and then what do I have to do to f of x to make it compress or shrink by a factor of 1/2? What's that? Times 1/2. Exactly right. It'll be 1/2 times f of x. Just like that. That's going to compress it now. Oops, sorry, it's off the screen. There we go. And that'll compress it by a factor of 1/2. Okay, right? That's that a value. Write that number out front there. Vertical stretch if a is greater than 1, but a vertical shrink if a is between 0 and 1. So 1/2 is between the 0 and 1. Okay, and guess what? It's the same idea as we did before. Okay, so we're going to take any coordinates here. So, well, for example, if we take 0, 0, okay, is that point going to change? Is the point 0, 0 going to change? Yeah, no, because what's half of 0? Still 0, right? Doesn't change. All right, let's pick some other points, though. Let's pick some other points here. So, for example, let's pick the point. I'll pick an easy point to work with here. Let's pick the point like right here, 2, 2. Okay, 2, 2. Now, if we're compressing it vertically, that means the x-coordinates don't change, okay? We're just going to compress it vertically here. So that means it's going to be 2, our y-coordinate, is going to be multiplied by 1/2. So what's half of 2? 1. So our new point here is now same x-coordinate, but just half the y-coordinate. So 2, 1, like that, okay? Let's do another one. Let's do like 4, 4, for example. Okay, we have that point 4, 4. Okay, but we want to compress it again vertically, so that means we're going to affect the y value. What's the new point? If 4, 4 is the point on the original function, what will the new point be? 4, 2. Right, again, half the y-coordinate. So 4, 2 will be right here. And so you can just draw that, connect the dots, kind of, right? And there's the graph of it on that side, compressed. And then we'll do the same thing to the other side, right? You can use symmetry if you want to. So if we have the point, for example, 2, 1, then we'll have the point negative 2, 1. And we'll have negative 4, positive 2. And we'll just kind of graph it that way using the symmetry. Okay, just like that. So there's our graph compressed. Okay. Questions on 8? Okay. Cool. Let's go ahead and do 9 and 10 because, you know, they're both some can do too. Okay. So number 9, for example, here. Oops, sorry, I'm off the screen. There we. Look at 7. There's number 9. Okay. Reflect the graph of f(x) across the y-axis. So here's the y-axis. Okay. So how can we go about reflecting this graph over the y-axis? Any ideas here about how to do that? Yeah, Stefani? Okay. So wherever we have, so what's going to be negative? I guess. Like how does that? Can you be more? So all the x values, any x value will then just become the opposite. Exactly right. So for example here, we have the point, I'm just going to go ahead and say that's like the point -1, +4. So the new point should be what then? 1. So the 4 will still stay the same, it's just the 1 that changes. So it's going to become +1, 4. So it's going to be right, oh gosh, I can't count. That's a -1, 3, by the way. I can't count. That's bad for a math teacher. Anyway, there you go. So we'll have the point 1, 3. Okay, so that's on our new graph. And then down here we have the point 1, -3. And so, Estefani, what is that going to become? -1 and then -3, because that one is still, the y-coordinate was -3. Okay, you can see, for example, this point here, it's 2, 0, so that becomes -2, 0, which is that point right there, and the -2, 0 will flip to that point. And so we can kind of draw it like this. It'll go like this. That, through the 0, 0, up and back down. So that's how it would reflect over the y-axis, right? You can just imagine kind of flipping it over that y-axis there. Okay. Flipping it over the y-axis. Should be equidistant, right? This one is 1 away from the line of reflection, so it's going to be 1 away over this way. This point's 2 away, so it should be reflected 2 points away over here. This point's 1 away from the line of reflection, so it should reflect in the opposite direction 1 point away. That's from geometry. Last one here we'll look at, and then we'll talk about even and odd functions. So there's number 10. And now we want to reflect across the x-axis. Okay? So now if we're going to reflect across the x-axis, what coordinates will change and what coordinates will stay the same in this case? So the x-coordinates, if we're reflecting over the x-axis, this point will reflect down to here. So the x-coordinate actually is going to stay the same, and it's the y-coordinates that become opposite, exactly right. So for example, let's just pick 2 points here. Let's pick the point, for example, like 2, 2. 2, 2 will reflect across the x-axis down here to 2, -2. Put a point. Okay. -2, 2, this point right here, will reflect down to -2, -2. That and 2, -2, like that. Okay, and so then in the 0, 0 is going to stay 0, 0 because it's on the line of reflection there, and so we just connect the dots and kind of continue the graph there. Connect the dots and kind of continue the graph there, like so. Excuse me. So there's number 10. Looks like a giant X, but remember we're just reflecting it there. Okay. Questions on any of that? Okay. So we'll try and get some more practice of that later. I think we used up all the problems in the book here, but I'll try and get some more practice of that tomorrow, so we can get more practice with the you know, the different transformations of things. All right. 2 other vocab terms I want to talk about here before we move on from this section. We're going to talk about even and odd. Okay, and again, the book has like kind of a more complicated definition, I guess I'll say, than what I want you guys to worry about. We're going to focus on a simpler definition, I think. Okay, so we can classify functions as being even functions okay, or odd functions. Okay, or you can also be, oh, sorry, I don't like way screen, there we go. Or they can also be classified as neither, right? So like, if a function is even, that does not mean that it must be, if a function is not even, then that does not mean it therefore must be odd, right? These are not like mutually exclusive, right? Okay, just because something's even does not mean it's necessarily then odd. Okay, it's you could be, but you can only be one. So either you're even, you're odd, or you're neither. Those are your three options. Either it's even, the function's even, it's odd, or it's neither. And so how can we tell which one it is? Well, if a function's even, that means it's really just symmetric over the y-axis. Okay, do y'all remember what that word symmetric means? It's like kind of the same thing on both sides of the y-axis. If you fold on the y-axis, it would match up perfectly, right? A function is odd if it has rotational symmetry of 180 degrees about the origin. Okay. Remember, 180 degrees, that is a half of a full circle. So it's like a half turn, not a full turn, a half turn about the origin. A function's odd if you turn it halfway around the origin and it still will look the same. Okay, and a function is even if you fold it over the y-axis. Okay. But of course, a function, okay, can be neither odd nor even. Okay, and I can show you some examples of that too. But a function can be neither odd nor even. And so actually there's a couple pictures in the book here we can look at to determine whether it's a function, to look at functions that are even or odd. Okay, so let's look at, for example, this first graph right here. Okay, let's see if I can get this all to fit on one thing. I can. Okay, so this first graph right here, does it look like it is symmetric over the y-axis? Could you fold this function over the y-axis and it would match up? Yeah, it is. So this function is an even function. Since it's even, it cannot be odd. All right. In fact, if you were to rotate it 180 degrees, it would not match up. Okay. So it's an even function, but not an odd function. Okay. Let me see if I can find some other examples here for us. I do have some already picked out. Okay. So here we go. What about this function here, number 13 on page 43? Very good, it's odd, right? It's definitely not even. If we were to fold this, the right-hand side would fold down to here, which does not match up, and the top part would fold over to here, which again does not match up. But if you were to turn it 180 degrees, in fact, let me do that here real quick. Okay, here it is. Actually, I think I can do it this way. Oh boy, now I gotta try and match up again. And there you can see it's the same graph, right? It's the same kind of shape. Okay. So either way, it's going to line up again. So it's 180 degrees. This is odd. Okay, that's an odd function. Okay. How about letter B here? Is this even, odd, or neither? Even. Okay. If we fold it over the y-axis, it lines up. Okay, it would line up perfectly. Is it odd? Yeah, no. If we were to rotate it 180 degrees, it would look like a smiley face. There would be a smile now. Okay, it'd be the wrong way. So nope, it's just even. Okay, and then about this function right here, is it even, odd, or neither? It is neither. Very good. If we fold this top piece over, it would not match up over here. If we fold the bottom piece over, it would not match up here. Okay, and like if we turned it, it would kind of be the same thing, but it wouldn't be exactly the same, right? You'd have like a little bump right in here, and then a bigger. So again, if we turn that 180 degrees, you can see it does not line up correctly. So it just isn't right. Okay, so right, that one we neither. Okay, very good. Questions on even or odd? Okay, hopefully that was pretty straightforward. Good. Okay, so now we're going to talk about inverses, and we are going to use the book for this. So page 47, and this should be super quick. Okay, super quick. And this is where we're going to have our assignment, is out of inverses today. I just had to catch up on the transformation stuff there, but now this is what we're doing today, is just inverses. Okay, so on page 47, okay, David, might we get your book out, page 47, okay, we're going to look at inverses, okay. Do you have your book with you today, Dave? Okay, thank you, sir. So the question is, what is an inverse function, and how do you know it is an inverse function? Okay, so, first thing we talk about, recall that a relation is any pairing of the elements of one set, the domain, with the elements of a second set, the range. So like a relation is like a more generic, more general kind of way to relate, you know, two numbers together. A function, we use that word function a lot, it's a specific kind of relation, okay, where every input matches to only one output. Every x value input matches to only one y value or output there. Okay? The domain elements of the domain are normally called, or sometimes called inputs. Elements of the range are sometimes called outputs. Okay? Okay. Let's see here. Oh, we're about one-to-one, all that other stuff there. Okay, so an inverse relation, so an inverse reverses the pairing of a relation. Okay, so that's the key thing. An inverse relation reverses the pairings of a relation. So, for example, if you look at a picture right down here, okay, here's the function. It pairs -4 to -2, 0 to -3, 1 to 2, and 4 to 1. The inverse of that function would then take the -2, put it in the domain, and pair it to the -4, and now in the range. So you see it just takes the -2 and -4 and whoop, flips them. -2 and -4. So then, here with the 0 and -3, it's going to flip them, and then what should go in this box right here? Yeah, 0, yeah, right? Okay. And then here, the 1 and 2, it's going to flip it and go 2, 2, and then what should go in this box? 1. And then 4 to 1 becomes 1 to 4. Okay? So that's an inverse relation. You just flip the x's and y's. Okay? So now if we look here, is this, so this function right here, this thing is a function, right? Every x value goes to one y value. Is this inverse of function? Is this also a function? Does every x value here go to one y value here? Yes, it is. So this one is a function. Okay? So this inverse is a function. Okay? Okay. Let's look at letter B. Okay, same idea. We're starting with another function right here. Okay, so these domain values, -4, 0, 1, and 4. -4 pairs to the -2, 0 pairs to the -3, and then 1 and 4 both pair to 2. So when we do the inverse, we flip that. -2 pairs to the -4. -3 will now pair to what number? 0, good. And then the 2 will pair to 4, and what other number? 1, very good. Okay. Now again, we started with a function, right? Each x value goes to one y value, right? -4 goes to just -2, 0 goes to -3, 1 goes to 2, and 4 also goes to 2. But again, 1, the x value, is going only to one y value. 4, the x value 4, goes to one y value 2. Is this inverse a function? No. Where does it fail? Dave? Yes, exactly right. Do you have a question too? Sure. Okay. 2 goes to 1, 2 goes to 4. Exactly right. So this inverse is not a function. So the point here that I'm trying to make is that if you start with a function and then take the inverse of that function, sometimes the inverse will be a function, sometimes the inverse will not be a function. Okay, so you just want to keep on your toes there. Sometimes an inverse of a function is also a function, sometimes the inverse of a function is not a function. Okay, so keep that in mind. Okay, so let's see here. All right, yes. So if we look at, let's turn the page there to letter C. Okay. Another way you can kind of think about a inverse, instead of just like flipping the x and y coordinates, it's also a reflection. If you look at the graph here, an inverse is also a reflection over the line y equals x. So here you can see is the original relation right here in the graph, right? You see you have the point like 1, 2, we have the point like 4, 1, we have the point -4, -2, and we have the point here 0, -3. Okay, so you can see those points all listed out right here. Now it's asked us to write out the inverse of that function. So for example, if we had the point -4, -2, that means we'd have the inverse point what? So if we originally had the point -4, -2, and the function, the inverse of that would be what? Yeah, -2, -4. Exactly. Flip them around. Okay. If we have the point 0, -3, -3, 0. If we have the point 1, 2, it becomes 2, 1. If we have the point 4, 1, it becomes 1, 4. Okay? And so then let's plot these points. So -2, -4. I'm going to go left 2 from the origin, right, and down 4. Right there. Okay, -3, 0. So -3, not up or down, so just -3, 0 right there is a point. 2, 1, so 2 over, and then 1 up from the origin. And then 1, 4, right 1 up, 1, 2, 3, 4 point. Okay. Now, what do you observe about the graphs of the function, the gray dots, and its inverse in relationship to the line y equals x? So here's that line y equals x. What do you notice? Do you notice any sort of relationship between the gray dots and the red dots and that line y equals x there? What can we maybe say? They curve? Okay, yeah, if we connected them, they might curve there, yeah. How are these gray dots and red dots related? Yes, they're reflected over the line y equals x. Exactly right. And that's going to be true in general, okay? The inverse is the reflection of the function over the line y equals x. Now let's think about why that makes sense. When we find an inverse, what do we do with the x and y coordinates? When we have an original function and we want to find its inverse, what do we do? What do we do? We have an original function and we want to find its inverse. What do we do? What do we do with the coordinates? Swap them. We flip them, right? Which makes sense because reflecting over the line y equals x, that swaps the x for the y, and the x for the y and the y for the x. It's saying y is x. So what was y now becomes x. What was x now becomes y. That's what that equation is telling us to do there when we reflect it like that. It swaps the x and y values. Okay? So, here is how we actually find the inverse. And we're going to find the inverse of some linear functions here. I think I want to do it back on my paper because they just have too much junk there to deal with. So we're going to go back to the paper here just to show you guys. All right, and we'll do 2 examples here to show you. All right, and then we'll be done. So we're almost done here. Just got 2 more examples for you, and then I'll get you guys started on your assignment. Okay, so bless you. Okay, bless you. How to find an inverse of a function. Okay, we already have kind of done that. We swapped x's and y's, right? But what if we're given like a function rule? So for example, let's say we want to find the inverse of, excuse me, f of x equals 3x plus 4. Okay. So here's our example, and we'll kind of like go through the steps of this. Okay. First thing we're going to do is substitute y for f of x. So instead of writing f of x equals 3x plus 4, we're going to write y equals 3x plus 4. Okay, that's our first step. Just change that f of x to a y. Step 2. Well, again, when we find an inverse, what do we do with our x's and our y's? We swap them. So we're going to do the same thing here. Swap the x and y variables. Go ahead, what were you going to say, Greg? We'll get to that. Just switch the x and y's. So in other words, we're going to rewrite it as x equals 3y plus 4. I just swapped them. But of course, we normally don't write our functions solving it for x. We normally solve for y. So now step 3, we're going to solve for y. So we got to get the y by itself there. Okay? So how can we go about getting this y by itself? Right now we have 3y plus 4. I want to have just y. So what's the first thing we should get rid of here? 3 is going to be the second thing. First thing we want to get rid of is that plus 4. How can we get rid of plus 4? Yep, we're going to subtract 4 from both sides. Okay, 4s are going to cancel. X minus 4, those are not like terms, so we just rewrite x minus 4 equals, and then the 3y there. Okay? And again, what's our final step here to get the y by itself now? Now we will divide by 3. So divide everything by 3 here. Okay, 3's cancel, so I'm left with y equals. There's no number in front of the x here, but what could we have in front of that x right there? Bless you. A 1. So it's 1/3 x. And then minus 4 divided by 3 does not simplify, so we're just going to leave it minus 4/3. And there is the inverse function. Okay? Now technically I shouldn't have stopped there. I should now write it as f inverse of x equals 1/3 x minus 4/3. Okay, and that's the inverse function right there. Okay, so substitute f inverse of x for y. Okay, f inverse, I know what it looks like. It looks like f to the negative 1 power. Okay, but we read that as f inverse. Okay, that's f inverse of x is how you read that. Excuse me. F inverse of x is how you read that. Okay, and that's the inverse function. Okay. All right. So I'm going to have you guys try one here. Okay, so that was that example, and I'm going to have you all try one. So I want you to try this one here. Find the inverse of f of x equals 2x minus 2. Okay? So same steps here. Substitute y for f of x, swap the x and y variables, solve it back for y, substitute f inverse for y, and that'll give you, so 4 steps there. All the same 4 steps we did. And I'll kind of come around and help as necessary. Actually, let me do it here. Well, actually, no. So give us a try. Try it. Find that inverse there. Try and find the inverse when we go. Okay. I'm going to try and find that inverse when we go. Okay. Second one. This is not on, I guess, technically on a page. It's technically on page 49. But you may want to try just on a scrap paper or something like that. You see they have like block flashing film, which might be a lot more work if you want to do. I don't know, you can try and find some space somewhere in there. Let's do it. You can just bring that together. Okay, so you got rid of 2. Be careful. When you get rid of 2 in front of that, you swap the 2x and the y. Just swap x and y. So it should be x equals 2y minus 2, and then solve. X equals 2. Good. Good. So far, so good. Looking good. Keep it up. Question? Yes, did you get to finish that one? Here is why. You would add the 2 over, so it'd be x plus 2, right? To get rid of the minus 2, you can add 2. So it'd be plus 1. Okay, you're welcome. Excuse me. Okay. Let's see here. Let's go to Jacob. Jacob, how do we do this? What should we do here? Okay, so so I'm going to take it, if you don't mind, one more step in there, and then so yeah, put y for f of x, and now you swapped it and made it x equals 2y minus 2 like that, okay? Added 2, so we get x plus 2 equals 2y like that?
Yep. Then I divide by 2 both sides.
Yep, so divide each little piece there by 2. The 2 and the 2, or 2y and the 2 cancel, so we're left with y equals, and then what's left? What's equal to? Very good. 1/2 x, and then 2 divided by 2 is? Yeah, there you go, plus 1. So 1/2 x plus 1. Okay, and there it is. That is the inverse. Now, how can you know that you have the inverse correct? And then I'll show you here. I'll show you that. Well, we'll talk about that maybe tomorrow. I'll show you that one more thing tomorrow. I'll let you guys get started on your assignment. Okay? Okay. So here's what I would like for you to do then. On page 53. Okay. Starting on page 53, we'll say at least. I'd like you to do number 1. Number 3. Number 5, 6, and I think 9 as well. That's on the next page there. Okay. I'm going to have you do 10 as well. Okay, now 9 and 10. You'll notice you're given graph paper there. You're given graphs, and that's because you are supposed to graph the original function and its inverse. Okay, so make sure you do that. Please do that. I want you to see what it looks like when you graph the original function and its inverse. Okay, all these things that we've worked with right now, they're lines, right? Just use slope-intercept form to help you with that. Okay, so go ahead and get started on that, and I'll come around and help you guys too. Okay, so again, page 53, 1, 3, 5, 6, 9, 10. Please. And I'll come around and help you as necessary here. Okay, Connie, when you started here, page 53, get those columns circled down so you can get assignment. It's okay, it's right up to the board. 1, 3, 5, 6, 9, 1. So you don't have to do number 2, just number 1 is fine. I know, I looked at that one, I was like, nah, too much. It's too complicated. Feel better, Adam? Feel better after you take that next part? Exactly, and then plot those points over here, so you can see the reflection over the line y equals x.
So why do you think that Caleb is crashing into you? I'm good.
Okay. So you think you're gonna be okay on these? You're okay. Okay. Yeah, good job. Okay, you know what to do for these? Perfect. Yep. Yep. And then you're going to plot those points over here. So you can see these points right here are already plotted, and then plot the inverse, and then you'll see that reflection over the line y equals x. Okay. No, I mean, why do you do that? You just want to know. Yeah, it looks good. So now what I'd like you to do, so you're going to plot the points over here, right?
Yep.
And then you should be able to see that reflection over the line y equals x. That was the whole purpose. See that reflection over line. That. Sorry, it's up here on the board, Andrew. 53, 1, 3, 5, 6, 9, 10. There's 6 problems, that's all. Some people are probably going to finish up before the end of class. Same idea. Start with y, make it to fxy, swap to x or y. Again. Okay, start on something. Read the directions. Okay. You have a question? Okay, go ahead.
I've already taken the class.
Oh, okay, gotcha.
And it took me my sophomore year and last semester. I got a D last semester. So I'm
Try to get those. Figure it out. Gotcha. Okay, cool. Well, that's, yeah, I'm happy to help, so let me know if anything.
Yeah.
Is there like, what do you have difficulty with?
Yes, synthetic division.
Okay, so when we get to that stuff, we'll make sure. we do
That's
it.
not until next term.
Yeah, I think you're right. It should be hopefully pretty easy for you.
Yeah.
Hope so. reflects over the line y equals x and would become an f right there. So that's the idea. Yeah, right. So then, yeah, exactly, for 10. That's the exact right idea. There's one other thing I wanted to have you guys, because it also says there's use compositions to verify that they're inverses. We'll talk about that tomorrow. It's really good, but I just wanted to get you guys get started on your homework. I don't want you to have to listen for any homework. You need to. Okay, so these look perfect. Can you try one of these just to make sure that you're okay with those two? Thank you, Connor. So, right, how do you want to inverse there? It's like what you did in the previous problem. So, what's the function they give you there? F of x equals what? 4x. Okay. So, what you did in the previous problem is you took your x coordinates and you swapped them with your y coordinates, right? So we need to put a y in here. Well, f of x is the same thing as y, right? So we're just going to put the y in for f of x. Then we swap them. And now just solve this equation for y. Get the y by itself. You know how to do that, okay? Okay. And that's it. And then once you have that, you'll have like y equals blah. And the last thing you want to do is just make it f inverse of x equals blah. So you'll solve for the y. You get the y by itself. You have y equals some stuff over here. You keep that stuff the same over here, but you just change the y to f inverse. That's it. Okay. Oh, right. Thank you. All right. I'll have to make sure to get these tomorrow. I forgot to get the warm-ups yet again, folks. If you've got them handy, you want to just give them to me, I'll take them. Otherwise, if you can get them tomorrow, that's fine. That's right. Have a good day, folks. Oh, I'll take it. Yeah. You can keep it. You don't have a fun shirt on today, Jordan. Is it underneath your sweatshirt? No. Nothing fun on today, huh? All right, fair enough.
Probably tomorrow.
Okay. I look forward to it.
Because I was all prepared to go, we're not even going to do homework lessons. Come in with any questions you have. So make sure they understood I was very impressed.
Now was that your AP week class?
No, it was geometry.
Okay.
Still a lot. Maybe explain why they all did it.
Right.
I would have figured at least one or two would have gone. I didn't get
Right,
that.
exactly.
I was out this weekend or whatever. Good.